All right, hello everyone. This is video 8 in my series, trying to learn the new programming language using Google's Gemini 2.5 Flash with a custom gem while solving problems off of Project Euler.net's archives to actually learn the language. So today we're doing problem 8. So let's go through our routine. Largest product in a series. Okay, so right, what is this problem saying? The four adjacent digits in the thousand-digit number that have the greatest product are 9, 9, 8, 9 equals to the product whose product is equal to 5832. All right, that's a gnarly looking thousand-digit number. Find 13 adjacent digits in the thousand-digit number that have the greatest product. What is the value of this product? Okay, so all right, so Control Z. Let's do 6. Okay, so there's this thousand-digit number, and what are the 13 adjacent digits in this thousand-digit number that have the greatest product? So if we have 1 and a 2 and a 3 up to 1,000 digits, what are the adjacent for, might be worthwhile doing something like this. Adjacent digits that have the largest product. 13 adjacent digits that have the largest product. So, all right, that looks like an interesting problem. So, I think what I'm going to do is, all right, this looks like a fairly interesting problem. So let's go through this. All right, so I think we are going to take the whole digit as a string, take whole digit as a string, whole digit as string. And then get the length of the string, get the length of the string. We definitely don't want to go past the 13th to the last digit, because that will be where the last 13 set of digits will come from. So we will take the length and then subtract the length by 13. Might have to do it 12 or 14. Let me think about that for a second once we get to the problem. And then we will start at the first number and start with two numbers, really. We will have the beginning digit of an index, A, and then the ending index for 13. So, for example, if we are at the first digit, we want to go up to the 13th digit. If we're at the second digit, we want to go up to the 14th digit. So what we need to do is start at the first digit, but then go up to the 13th from that digit, and then keep doing that for all other digits. But before we do that, we need to map these digits from string to integers. String to integers. Okay, we need to map these digits from strings to integers. Let me do the respectful thing here and actually spell this out properly. So that will be 4. That's 5. Or maybe I should just do this so that I don't have to keep changing numbers if I remember something new. We need a placeholder for our current product. Current product. We need a placeholder for our sequence of 13, our current sequence of 13. And we need to iterate through. So this was a placeholder for the current 13, the index of the current 13 digits, but we need to actually iterate through them through the 1,000. Get current 13, get current 13, get product of current 13, if current product is bigger than the last current product, take note, else continue. Continue, and then finally print the echo the largest digit. I think that's it, right? So this looks like a fairly involved problem. All right, let's see if we can get this done. Okay, so we'll be doing nvim problem 8.nym. All right, so something I learned in the background about the NIM programming language is NIM has two ways of declaring values, let and var. In the NIM programming language, what is the meaningful difference between let and var? So I'll let Gemini do a little bit of explanation. Let is for immutable bindings and var is for mutable variables. So if you declare something with let, you can't change it, but if you declare something with var, you can. So that's kind of useful. So the first thing we want to do is declare the whole string of 1,000 digits. So that'll be let the number string equals to, I have it copied here. So, and then we need to get the length of the string. Let the length, it's int. This is also, so the string is not changing and the length is not changing, so I want them to be immutable. That would be len. All right, so my LSP is saying it's len, so, but I still want to ask how to get the length of a string in the NIM programming language. len. Okay, that seems right. All right, len, the number, and now we need to get the last digit to go up to. So what I mean by that is if you have 1, 2, and 3, 4, 5, 6, 7, 8, 9, then we'll do 0 and we'll do, sorry, 0 and 1 and 2 and 3 and 4. So what you want to do is the first 13 digits are these, and then the second 13 digits are these. So what you want to do is you want to stop before you reach this point. You want to stop. What you want to do is stop here. So if you have 14, the way to do that is the length, the len is 14, but the index only goes up to 13. The index goes up to 13 because this here has the index of 0 and this here has the index of 13. So what you want to do is you want to stop at the index of 1 if this was your thought, if this was the number you were working with. So index is 13, maxes out to 13. So the way to do that would be 14 minus 13 gives you 1. So length minus len minus 13 is what gives you the number where you want to stop, right? So for that, I think our number is 1000 minus 13. So I think let final index int equals to the length minus 13. All right, we have that. And we will now declare place holders for the final final number, or for declare placeholders. Sorry, that should be what I should have said. Var current index. We start at 0. We start at the first number. The lower bound of the current 13 digits of the index of the current 13 digits. We don't need an upper bound because we can just get that dynamically. Var current sequence. Seek int, I believe. In the NIM programming language, how do I declare or create an array, a dynamic array of type index, of type int. Yep, so var my sequence int. Okay, cool. This will hold the current 13 digits. Now I think this is the most interesting, this might be the most interesting, one of the most interesting things we do in this task. Convert the string. Oh, we also need current product equals to 0. Yeah, let's do that. That was not what I was talking about, but convert. So this interesting task would be converting this string up here into a sequence of digits, string to a sequence of digits. All right, so this ought to be in the NIM programming language. So what I want to do is, gosh, that browser functionality is bothering me today. Okay, so we have a string. I want to take a string of digits. I want to take every digit here and convert it into an int type. So string to int type and then hold it in a sequence, seek. A lot of functions have, a lot of programming languages has something like a lambda function or mapping or a apply function where it is incredibly easy to apply the same function to an array, which a string is basically an array of chars. So thinking about this, I think the way to do that would be, the question I want to ask is, I have a string of digits, made up of digits. How do I convert that to a sequence of integers? So the question is, in the NIM programming, oh gosh, in the NIM programming language, I have a string of digits. I want to now convert to make an array seek can be immutable or mutable, whatever is better, of digits. I want to do this by applying a function that will convert all chars of the string into type int and hold it. Does nim have something like a map or a lambda or apply functionality or something analogous to it? If yes, please provide an example with well annotated syntax. Yes, nim has functions and iterators that allow for transformation similar to map. You can use the map function from the seekutils module. Okay, so map proxy char return type int. Oh, okay. So seekutils and stirutils. So we need this. So import required libraries. So the way to do that seems to be, what I want to do seems to be, so I will say this, hopefully this isn't a bit confusing, but I will say the numbers, and I will say the number. So this is the number, and these are the numbers. And so what we're effectively doing is the map function takes the number, this, and for every char in the number, it applies ORD, I assume that's ordinal, so um, but let's ask, what is ORD and what are you doing with it? ORD is a NIM built-in procedure that returns the ordinal or integer value of an enumeration type or a character. So ORD is something that will take a string with digit 1 and return it as an int. In the previous example, ORDC minus ORD0, we are using it to convert a character digit 0, 1 to 9 into corresponding integer value 0, 1 to 9. Okay, so even in the C programming language, you can do something like you take a digit of 3. Sorry, let's do this. And you can subtract 0 to get integer 3. So you go from char 3 to int 3, and that's because of the nature of the ASCII table that you can look into. But for now, that's how you do this in NIM. All right, so we have this, and so we have current product, and we have all our placeholders. We have the string, we have the length, we have the final index. Okay, so I think that's it. Oh, and I think we also need somewhere around here a way to get a product of all digits in a sequence. Product of seq. So I see. Okay, so in the NIM programming language, is there a canonical way to get the product of all the digits in a seq? Yes, the canonical way to do this in NIM is by using a reduction operation, specifically the fold L template from the seq utils module. Fold L, fold left is used to combine the elements of a sequence into a single value by applying a binary operation sequentially. For calculating the product, the binary operation is multiplication. Okay, asterisk, you need a starting value, which for a multiplication is multiplicative identity 1. Here's an example. So here's a sequence. Product is for sequence digits, you will do fold L digits A times B 1. Okay, so interesting. All right, so now we will do while current sequence is less than last or final index, we will do current sequence equals to we also need to ask, how do you get current 13? So how do you subset a bigger sequence? How do you subset a bigger sequence? Okay. In the NIM programming language, how do I subset a seq between x and y indexes? You use the slicing syntax with the dot dot operator. The end index is inclusive. Okay, so for mySeq, let subset equals to mySeq 1 dot dot 3. It echoes subset. The output should be 20, 30, and 40. So one. Okay, so 1 is so 0, 1, 2, 3. So 20, 30, and 40. Okay, so current sequence is the numbers, and we will do current index dot dot current index plus 12, because if you think about it, For 1, you want to go up to 13, so 1 plus 12 is 13. And for 2, you want to go up to 14, so 2 plus 12 is 14. So you want to add 12. Current oh, var new product int equals 2. So the new product is fold L, current sequence A times B, comma 1, if new product is more than current product, I want to change current product to final product. Yeah, I think that's much better. Final product. Final product equals to new product. And we do current sequence plus equals to 1. Oh, nope. And then we will do echo final product. Type mismatch. Oh, not current sequence, but current index. And while current index, right? Oh, okay, so while current index is less than final index. Okay, so I think that's it. So what we're doing is we are starting with the first number, 0, and then getting the product of this 13. We're taking a note of the product, and if this product is larger than the previous biggest product, then we replace the placeholder for the product, biggest product, with the current value, and then we go to the second number, and for here we only have 14 digits, but we keep going until the last 13. So that's what we're doing. See, all right, so let's see if that compiles. Problem 8 is what we're compiling. Okay, that's a huge number. 2351, 462, 4. 2351, 4624, 000. So can I do paste? Oh, I can. Oh, I should just start doing that. So let's see. Let's go to Project Euler, sign in, password, CAPTCHA 746, product 8. So 2351462400. That was what we got from my terminal, and this is what we got from, this is what it should be the answer, so 2351462400. Ooh, nice. So one more time, what we did is correct. Huge smiley face, and that's we got the correct answer, so that's fantastic. That was time problem 8. That was milliseconds. That was really, user time was practically microseconds, and this is very easy to read code. You import libraries, and this is, in some ways, this is I like this more than Python. This is very good. incredibly fast and very good. I am constantly more and more impressed with NIM. So in this, so that's fantastic. But let's think about all the things we learned here. We um, we learned about the map function from NIM. We learned about the fold L, which was very useful. We learned how to subset a bigger sequence, and we solved the issue. So this we learned 3 or 4 new things, and we solved this issue with a fantastic solution and fantastic implementation. So this is great. So I'll see you guys in problem 9. But yeah, I'm constantly impressed with NIM. This is great. All right, see you guys.